Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Baraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're back with the IPv6 Basics series, and our topic this time around is link local addresses. So I guess we should dive in and actually talk about what the heck link local addresses are, why they're used, what they're all about. So I guess we should start off by defining actually what the address space is for link local addresses. I guess that's a good rational starting point. And most of the time, you're going to see documentation that writes it as FE80::/10. And that's the address space that's designated for link local addresses. And I guess we should talk the next thing about what the function is. So what do we describe the function of link local addresses? I guess the name sort of describes it a little bit.
Yeah, well, poking around in the RFCs, trying to figure out the canonical definition of link local. And of course, it's in 4291, which is the address architecture RFC. But then you pointed out in RFC 5156, they throw in the word link scoped unicast, which is the critical word, right? I mean, if we really want to talk about what's unique about link local addresses, the fact that they're scoped only to the local link, I think is probably the first critical piece of information you need about those addresses.
Yeah, I think that makes a lot of sense. I think FE80::/10 seems like a really big prefix range for something scoped locally, but
there's a secret about that, right? There's a trick to it.
Yeah, they simplify it down to a 64, just like everything else in IPv6. It should be at 64. So FE80::64 is how you actually see it implemented from an operator standpoint. But FE80::/10 is what's reserved for the purpose of, in case they decide they need some additional address range for a different link local scoping purpose, which who knows what that could be, but that's just reserved for future. So we have a much bigger address range that's sort of set aside for future use or science experiment or whatever they want to do. But FE80::64 is how you should see it practically implemented.
I don't know, is a /10 a lot of addresses?
It's a fair amount of addresses.
It's a fair bit.
Fair number.
It's bigger than the documentation prefix.
This is true. Curses!
You should work on that, Nick. There's more link local addresses than there are documentation.
Oh boy. Nope.
And we've sort of described from maybe a purely definition standpoint that they're scoped locally, but let's talk about it from an operator standpoint. Really, these are addresses that a host operating system can, number one, self-provision, right? They know to go ahead and build a link local address because they need one automatically to participate on a given network segment, and they're going to build one for every network segment they participate in. So if you got a wired interface, a wireless interface, a VPN interface, every single one is going to have a link local address, which means every single interface is going to have an address in the FE80::64 address range, which seems to violate the principle of globally unique addresses. But you have to remember, these are scoped locally. It's okay to have addresses in the same repeated prefix space. It's not a problem. You probably won't actually build the same address. You could build the same address on every single interface, and we'll talk a little bit about scope IDs as it relates to this. But the reality is you technically could have the same link local address on every single one of, let's say you had those three interfaces, you could have the same link local address across all three of them, and that would not be a problem, which seems like a strange statement for us to make in these globally unique V6 address space world, but that's just the reality of it. And really, the design goal of this is to allow devices that may not have a router or may not have a global unicast address allocation method set up on that particular network segment to still allow host devices to talk and communicate to each other. So this is in some ways sort of similar to a PIPA in the V4 world of self-assigning a V4 address, just to allow us to be able to communicate with the IP protocol on a given LAN segment. We can do the exact same thing with link local addresses. And in fact, we can use multicast DNS to find each other and discover services and do all sorts of fun things just with link local addresses. You don't need a global unicast address at all. This allows you to set that up and go ahead and do that. You still have issues with duplicate address detection. So that still happens with link local addresses. So the reality is that you still do that process for link local addresses. You'll come up, bring your interface up. You'll do all the multicast goodness to discover if someone has the same interface identifier as yourself within the scope of FE80. It's just everyone has the same prefix FE80, but your interface identifier, that's what you're really checking to see if that matches. So your solicited no multicast address gets built. We talked about that previously, but it's a special address that gets built out to allow us to hoot and holler on the wire via multicast to discover if someone else has the same interface identifier. So you're still going to do a check locally to make sure that you don't have a duplicate address. Did I miss anything there, Tom, Nick? That sound correct?
Yeah, I think the interface identifier is one thing that's somewhat perplexing when you first kind of figure out what it is. You probably want to expand on that a little bit. But one little anecdote that I used to use when I used to teach the V6 workshops, the statement was specifically crafted to get the students to ask questions, was link local is the IPv6 you have when you don't have IPv6.
Hmm.
Because back when I was teaching this, IPv6 was significantly less common, even in mobile carriers, but it was available in certain operating systems. And when you do like an if config, you'd see that FE80 address. And I would have, the purpose of that statement was to get them to say, well, what do you mean by that? A statement doesn't make sense. But it's the thing that'll allow you to do all the local stuff on your LAN segment if you don't have anything else.
Right. It's sort of interesting. This is that we don't talk about it too often, but that latent threat portion of the conversation when V6 is turned on by default, right? May not have a global unicast address, but it definitely probably has a link local address and is able to operate and provide services off of it, communicate with it. And so that's sort of what's implied by that latent threat of V6 operating and running. And so you might have seen some articles recently talking about exploitations of RA advertisements and things of that nature. They're making use of not necessarily link local, although link local is running. They're making use of the fact that you haven't secured your V6 in the way that you probably should have, even if you're not running V6 actively. Let's talk about how we actually set up link local addresses. It sounds like in most cases, they're just set up automatically for us, right? So the host operating system does its thing, but that's not necessarily true for network equipment. I mean, I guess you can manually set link local addresses. It might serve you better than using the default. I think most network equipment uses the default of the EUI64 version, which means the MAC address that's assigned to that particular interface, gets expanded. The FFFE stuffed in the middle, the global to local bit is flipped, and we've got our interface identifier that's set up for that particular interface, which works great for network equipment because they all have unique MAC addresses as they should, and they're designed specifically to do that. And I think for most network equipment, it doesn't really matter, but there might be some advantages of manually setting up your link local address. So maybe we talk through those really quickly, which I think they're probably more common in LAN use cases, right?
Yeah, the instance where maybe you prefer to have the same sort of default gateway configured everywhere. And so the link local address gets set on a gateway device to be FE80:1 as an example. You can repeat that everywhere you'd like to use it because it's only significant to the local scope, as we talked about already. And so from a provisioning and a network maintenance standpoint, there's some benefit there in just having a standard that everybody follows for gateway addresses for devices that uses that FE80:1 address. And that's perfectly doable as long as the device allows you to configure the link local address manually. And I think the consensus is that most devices do. I think there's probably some legacy gear out there that may not support it, where you're stuck with the UI64 formulation. But yeah, that's one aspect of it.
Yeah, and there's some pros and cons, right? I guess if you make the mistake of plugging one VLAN into another, then you're going to have a duplicate address and one of the default gateways is going to go away.
Yeah.
Right.
I would argue you probably have other problems.
That's right.
Other spanning tree related issues? Yeah, you probably want to go figure out why someone plugged one network VLAN into another. But I think those are good points. And if you're running highly available default gateways, maybe you're doing FE80:1 and then 2 and 3 for the actual interfaces of the devices, or you're reserving them depending on how your device fails. Maybe some popular firewalls, they don't actually use two addresses. They just fail between the singular address and just do fast updates for redirecting the traffic over to the active device. So just depending on your setup, but you might want to reserve a few of those just in terms of how those are handled. I guess, Tom, this is a good question. We don't stick link local addresses in any sort of IPAM system, do we?
Well, I suppose you could try. That would cause some confusion back in the sort of the early days of IPv6 IPAM, where discovery is a thing. And it's like, what value do these addresses have? And, what value my IPAM is providing? And, because of the local scope, and there's very little case to be made that you need to track those addresses at the IPAM level. But it certainly, if it accepts a valid IPv6 address, there's no reason why you couldn't shove one in there. But what you're doing with that information is probably not very useful from most perspectives.
I could see maybe if you're going to configure the routers, like maybe just putting that address in there for reference, maybe.
Yeah.
I don't know. I've never seen anybody do it.
maybe almost more useful as like an extensible attribute, the link local address associated with the global unicast address that, because that does bring up the other point related to routing, which is that, link local addresses show up as next hops. And when you're looking in the ribs and the fibs, you're like trying to determine how traffic is being routed. It certainly threw me the first time that I saw it, where I was expecting to see a global unicast next hop, and then I saw link local next hop instead. And then you have to tease out like what's going on here. So definitely something to be aware of.
Yeah, and I think that leads into the next natural question, which is there any point of matching my global unicast interface identifier with maybe my link local? And I think there's some indication that that could be useful in certain scenarios. I think definitely in WAN, your WAN backbone and some of the routing configurations, it can be incredibly useful, especially if you're doing small things like embedding maybe router IDs inside the interface identifier. So not up in the FE80::64 side, but in the lower portion of the interface identifier side, if you're doing things like tagging VLAN IDs or tagging router IDs as part of additional sort of metadata inside of the actual address itself, then it becomes more useful and you can have an idea of like, oh, well, I've got an OSPF neighbor peer relationship with router 5 or whatever it is.
Yeah.
You do all have to agree that are you going to do everything in decimal or hex in terms of identifiers, because that's important too. So that's a whole different standard thing, and we won't talk about that here, but it is something that will come up as you start working your way through it. Are there other considerations, around sort of link local addresses in general? The one thing we sort of skipped over really quickly was scope IDs. Do we want to talk about that quickly?
I did want to bring up, you said it, but I want to reiterate as one of the things also that Tom agreed about was that the first time you're looking at your routing table, like on your host, and you see an FE80 address as the gateway of last resort, I was also confused when I saw that until I realized what was happening and why. So for folks that are like just getting started and they're trying to figure out like, what are all these addresses used for and why am I using this and why is my gateway this number that I didn't configure when I have these other things, it's important to realize like this is probably the most visible thing that you would see in a link local address when you're starting to troubleshoot stuff is it's going to be your next hop router. When you netstat -6R in or whatever, and it prints up the route table, just saying those words, if that helps one person not have to kind of go through like, huh, head scratching, what's going on here? I think that's worth saying.
Yeah, and part of the advantage of link local scoping of this way is you have to remember the router advertisements. If you go back and listen for the other basic shows talking about router advertisements, this does allow you to readdress networks because you can change what the global unicast address range is. But guess what? You're not necessarily, well, your router, it doesn't change. So the next hop, you can have two sets of global unicast addresses active at the same time, which allows you to renumber gracefully, giving an overlap of time period to switch from one address space or one prefix to another. So that gives you that sort of unique capability to do that.
Can confirm. That's very useful.
Yeah. Just don't be surprised when you see FE80. You should see it on every single interface. It should be technically the second most common address. I think technically multicast addresses are going to be more common because you're going to have a solicited no multicast address built for every single, both link local and global unicast. And if your link local doesn't match your global unicast, you'd have two multicasts for each one of those. Plus you have the multicast listener for, all hosts. So I think technically you have more multicast addresses than you have either unicast or link local. I don't know. I'm getting pedantic now.
And that's sort of one of those things where there's not an easy way to look at them, the multicast addresses. You have to run to figure out what multicast groups you're subscribed to.
Yeah.
You're probably familiar with, a lot of the other commands to look at addresses on interfaces and that sort of thing. But unless you had to debug and troubleshoot the miserable world of multicast at the host level, you're probably not as familiar with how to see those address subscriptions.
Yeah, and those multicasts are really on link multicasts. They're technically layer 3, but they're really combined to the layer 2 basis for the purpose of what you're doing there, which is really just to scope it down to the Ethernet multicast groups for listening, for basically getting transmitted on the local wire. That's something just to be aware of. Is there other weird or odd things around link local addresses that we should bring up? I mentioned the scope ID thing. The scope ID is really just saying what interface that particular link local address is associated with it. So if you have a Wi-Fi interface, you're going to have some sort of scope ID in the local OS that says like, hey, this is associated with this particular interface. It could be a number, it could be a sequence of letters, it could be the actual name of the interface. It doesn't really matter. But the point of the scope is to really say like, hey, this FE80::1, if you're trying to ping that from your local host and you're connected to 3 different networks that all have FE80::1 as a default gateway, which one do you want to send that ICMP packet out of, you got to tell it. So that's where the scope ID comes in. It says like, I want you to send it out my wireless interface, or no, I want you to send it out my wired interface, or I want you to send it out my VPN interface. So which interface do you want to use to actually send that traffic? So you're just basically specifying the layer 2 media type that you want to go ahead and send it out. And so your operating system or your network device will have a scope ID that basically identifies that particular interface to be able to do that. So that way you can do things like ping FE80::1 if it's on multiple network segments and you're connected to multiple network segments.
Yeah, and on routers and switches, it just forces you to tell which interface you want to send the link local ping out of in the absence of a scope ID.
Yes.
If we revisit the WAN topic again, I mean, and this is something you'll probably maybe run into relatively quickly, especially if you start digging around link local and WAN. And, as we know, BGP is very finicky about next hops, but it is possible to build your BGP peering relationships over link local addresses exclusively. And I think there's even an RFC that was it Eric Vinke and folks cobbled together.
Yep.
That's definitely a design option. I don't know that we've actually seen it in the wild. There are pluses and minuses potentially to taking that approach, but it is something that you may run into if you're doing your due diligence on link local and WAN, and you may see that RFC crop up. I guess maybe it's like an old school V4 prejudice that's sort of seeped in related to how I've configured all my BGP sessions over the years, but never seemed to have much of an appeal to me. But I know that there are potential advantages to it. But what do you guys think?
It's like IP unnumbered, right? And IP number unnumbered seems like a great idea until you're trying to debug it. You're like, why isn't this working? So yeah, I have similar sentiments to you, Tom. I just use global unicast addresses for BGP. It makes it easier. It's also easier to read the global routing table. It also ensures that you can do ICMP path MTU discovery for every single hop and put your filter someplace else if you don't want someone to look at what your path is. Filtering is a whole different discussion, and maybe we can touch on that briefly. But yeah, that's my take. I think for interior routing protocols, OSPF, EIGRP, RIP, stuff like that, you're going to see all of these use link local interfaces automatically to sort of build their dynamic peer relationships and do all of that. And that is expected behavior per the RFCs. That's actually in the RFCs about how they're supposed to do that. You can force them to use global unicast addresses, but you're sort of wandering in territory of like, okay, well, you're having to go outside the norm in configuration work to actually set that up versus just using link local addresses.
Yeah.
Anything to add on that?
The IGP thing is a really good point. As an experiment, I built a big OSPF3 mesh using no GUA address space, and it just works. And I think that's a very useful tool in the toolbox if you say need to renumber a wide area network. Like I've renumbered a wide area networks point to points in the middle of the day for V6. Nothing happened. Like those are there specifically for trace route and troubleshooting purposes. If you don't have them, you'll run into all those IP on number problems. But from the point of view of an IGP, they don't use the protocol that they're routing per se to do their communication, which is a powerful statement, really, right?
Yeah,
because they don't rely on that at all. They can stay up and running even if you completely misconfigure point-to-point addressing.
So, Nick, are you saying our listeners at home should be entirely comfortable with renumbering their point-to-point links on the middle of the day on a production network using IPv6?
I mean, do what I say and not what I do.
Do what I say. I say renumber.
No, I don't know that I recommend it, but
yeah, it's a tool in its toolbox, I think is the point. You have the flexibility of the tool, what it offers. I think it's really important, especially for those, I think probably the two most common routing protocols you're going to see and operate with for V6 and probably for V4 now is really OSPF and BGP. And, take the time to learn really and understand that the LSA types are the important thing, not what's in your routing table. On the OSPF side, anyway. Once you really understand that, you can understand a lot more about what's going on, and link local addresses suddenly make a lot more sense in terms of what's happening. It's just one of the things to be aware of. Do realize, I guess maybe we talk about filtering really quickly because that's sort of related to a routing discussion, because there's probably some do's and don'ts. Don't filter link local addresses if on a direct interface. I mean, you don't have to accept them from the public internet. I totally get it. You want to build a bogon list. I think link locals probably don't belong there, except for you still have to accept them on the point-to-point link for your upstream ISP. Otherwise, guess what? You're not going to make it across the hop. So do realize you have to be careful about how you're doing filtering and where you're selecting to do the filtering, right? I think that's an important point. I don't know, Nick, have you seen anything catastrophic that's happened from people filtering link local addresses incorrectly or
I've seen instances where there's just overly aggressive filtering, link locals in the list, and things just don't work. It kind of is in the same boat in my mind as ICMP, less is more when it comes to filtering these specific things. And it's important to remember that they're scoped to just the segment. So if you're filtering, you're essentially filtering things from communicating within that same segment. You don't need to necessarily protect from, bad actors out in where the dragons are, right? Because it's locally scoped.
Right.
So, less is going to be more there.
You take a different policy than your global unicast address space is, I guess, the point.
That's a much better way of saying what I stammered out there.
You're welcome. As a final note, I think there are some weird vendor implementations. Sometimes you're going to see a few oddball things out there. And if you play with enough equipment, you eventually run into something where maybe the link local address space isn't what you expected or behaving the way you think. We had someone who didn't know V6 and saw the link local scoping and went ahead and set up FE90 and it worked. And we were all like, what happened? That doesn't make any sense. Because it's within the FE80::10, and that's what the vendor had implemented within their code because that's what they read in the RFC. So just realize you might see some oddball things in there and it may not work consistently for those. And so this is the one use case where I say, like, just let the device configure its own link local address. You might be better off versus going in and manually typing FE90::, and whatever interface identifier you want to set up and see if you can get things to break. So just one more thing to add to your test plan as you test your proof of concept and everything else that you're working on.
Other thing I would add just for folks that are getting started with it, I mean, because you have this valid layer 3 address that's being configured at boot up on the host OS without any interaction with the rest of the network other than messages that are sent out from that host to determine if the address is already in use, that sort of thing. It's really a great place to start when you're just getting your feet wet with IPv6, recognizing that you don't need a global unicast address to start looking at some packet captures and seeing some exciting IPv6 action happening on the wire, as it were, just based around your host. And as you've already mentioned, Ed, there is a latent thread issue associated with that. The fact that you do have a valid layer 3 address that can allow communication on a local link between different nodes. From a security perspective, maybe that's not something that you want, but definitely don't just turn it off. Figure out what's going on and manage it, and have that be the basis for the rest of your global unicast address based IPv6 adventures.
Yes. And the reality is, something else needs to be exploited on your network to exploit that next link local sort of side channel.
That's right. At that point, the call's coming from inside the house. So,
Yeah, for sure. I think that was a pretty good coverage for link local.
And if we missed anything, send us your questions and your bouquets, your brickbats, etc.
And don't be confused. There is an older RFC that describes something called site local. That's not the same as link local. So I just want to be really clear about that. And site local was deprecated. You shouldn't see it in use anymore. It shouldn't be something that if you're reading a blog article or something else and it's talking about site local, you're reading a really old article. Find something newer because, it doesn't exist anymore. So link local is the thing, and that's what you should be seeing and using. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long, and until next time, we'll see you on the IPv6 internet.